All right, welcome to this class. Today we have radioactivity question for us to solve, okay? And if you look at this question, we're going to deal with it in a very simple way. Let's start with the question. They said that a radioactive isotope of americium of 241, which is the atomic number or the atomic mass, decays into a nucleus of neptunium of atomic mass 237 and an alpha particle as shown. So that means this is a nuclear reaction. In this nuclear reaction, this is just what happened and it came from this equation, but the equation is lacking some values which we are supposed to fix. But then they said we should state the number of neutrons in the americium, and then we also determine the value of the A, B, and C. The best way I'm going to solve this equation is to start having the idea that this nuclear equation, or this kind of radioactivity gave off alpha particle. For it to give off alpha particle, I'm going to write a general equation for unstable elements that gives out alpha particle. Look at the general equation. That general equation is given as, let me call this A to Z of a particular element. Whenever an element is not known, whenever you use a letter to represent an element, we call it nuclide. So there is a nuclide. So whenever this nuclide gives us alpha particle, this is what you're going to have. The element that will be formed here is going to have A minus 4 and the Z, which is the atomic number, minus 2. And that element, I do not know the name, so I'm going to use Y to represent it, which is a nuclide. Then plus, because this is an equation involving alpha particle, I'm going to write a helium atom, because helium atom is something as the alpha particle. It's going to be 4, which is the atomic mass, and 2, which is the atomic number. So this is the general equation. If you look at this equation, it is the same thing as this equation. So I'm going to compare them. If you look at them, this is representing this, and this is representing this, and this is definitely this. So for this reason, I have already found my ABC, or I have already found my AB. So from this, I'm going to say comparing BA, which is alpha, with this 4, 2 for the helium. This implies that B is 4 and A is 2. So we have found AB. Let us find C. For us to find C, we need to compare this one with this one, because everything here is going to be compared with this. Now for that reason, everything here as well is going to be compared with this. So whenever you have an alpha particle equation, use this as the general equation. So I'm going to say that A is representing 241 and Z is representing 95. So I'm going to have that. This is what I'm going to have. A, which is what? 241. This is for A. Okay? Minus 4, which is going to be equal to everything here. Alright? Of course, it should be. Look at this. 237. Have you seen that? But our intention is to find C. So I'm going to use this, which is Z is this. Z is 95. So this is going to be 95 minus 2 is going to be equal to what? C. Therefore, C is something as what? 93. So I have found C, I have found A, I have found B. So the question is, state the number of neutrons in americium. Alright, so as we have found the C, we have found the A, and we have found the B. So we are going to find this neutron. But remember this equation, whenever we talk about neutron, we are relating it with atomic number and atomic mass. But look at this. A is equal to N plus Z. Always know that they are in alphabetical order, in ascending order. The lowest is A, the next to A should be N before Z. So Z is the last. Therefore, the issue is, what is A? A is always the atomic mass. So since our intention is to find this for the American is this one, AM. We have A, which is given as 241, which is equal to. We are looking for the neutron number, which is N. I do not know N. Plus Z, which is the atomic number, is going to be 95. So I have 95. All right, that simply means that N is going to be 241 minus 95, and N is going to be equal to 11 minus 5 is going to be 6. What is remaining here is 3, which is going to be 4. All right, so the value there is 146 is the neutron number of this equation. Thank you so much for being part of this class. Remember to hit the subscribe button, like this video, and